Hi, I'm Uncle Sayed, a field engineer at Wallaroo. In today's demo, we'll explore how Wallaroo enables enterprises to deploy, migrate, and manage agentic AI workflows securely, at scale, and with a consistent experience across any environment and hardware platform. Whether in the cloud, at the edge, or on-prem, Wallaroo makes that process seamless across different combinations of environments and silicon, all while preserving the same streamlined workflow for deployment, inference, and lifecycle management. Wallaroo puts you in complete command of where and how AI agents are deployed, updated, and integrated. Let's get hands-on and dive into today's demo to see how. For today's walkthrough, we'll work in a Jupyter notebook, though the same workflow applies in any Python development environment with access to your Wallaroo installation. We'll begin by importing the Wallaroo SDK, a pip installable Python package that provides the interface for working with Wallaroo. Then we'll connect to our Wallaroo client and workspace to finish the setup. With our setup complete, we're ready to upload our open source LLM. For today's demo, we'll use Llama 3.1ab, uploading it with the help of the upload model function. To it, we'll pass a few key arguments, the model's name, and file path. The framework vLLM telling Wallaroo to optimize our LLM's runtime for it is as simple as passing it as an argument. Critical for agentic AI applications, optimizing our LLM for high throughput, low latency inference. Along with that, configuring the vLLM parameters is just as easy. We'll set the max model length to around 10,000, allowing efficient runs even on smaller accelerators. Next, we'll set the accelerator and architecture on which our Llama will run. Because Wallaroo is silicon agnostic, this isn't just about configuration. It's about migrating inference workloads seamlessly across accelerators and architectures. By simply setting the accel parameter, we can move from NVIDIA's CUDA, AMD's ROCm, Qualcomm's QAIC, IBM's Spire, Intel's Gaudi, or another accelerator. Similarly, the arc parameter continues that paradigm to allow us to just as easily do the same across different hardware architectures. The best part is, Wallaroo comes with all the built-in dependencies needed to support this migration of agentic AI workloads and LLMs. And even with these optimizations and hardware migrations, uploading and preparing our LLM is done in a matter of minutes, often 10 or less. Once uploaded, in addition to our LLM leveraging our accelerator and vLLM, we can further optimize its throughput and efficiency by configuring use continuous batching, maximizing our AI agents' performance on our hardware. Next, thanks to Wallaroo's OpenAI API support, we'll configure our open source LLM to use the industry standard OpenAI API, making it immediately compatible with existing SDKs and tools. Now that we've uploaded our Llama, configure it for our accelerator and architecture, optimize its throughput and efficiency, and made it OpenAI API compatible, we're ready to configure our deployment hardware. This is where Wallaroo helps abstract away the complexities, simplifying how we configure our hardware, providing a consistent experience regardless of the silicon. With it, we're able to define the allocation of deployment's resources, along with the amount of replicas, and if we'd like it to autoscale. Wallaroo's deployment configurations strike the perfect balance between abstraction and fine-grained control. By allocating CPUs to handle data transport and local balancing, we're able to dedicate our accelerator entirely to our LLM, maximizing our Llama's performance and any optimizations such as continuous batching, allowing us to ensure optimal resource usage. Once our configurations are set, we can deploy our pipeline. We'll give it a name, add our LLM, and deploy it using our configuration. Wallaroo takes care of automatically deploying it to the correct silicon. Once deployed, we can retrieve our pipeline's API endpoint, which can then be integrated further into our overall agentic AI workflow. Using the API endpoint, let's try inferring on our pipeline. Because we configured our Llama to be OpenAI API compatible, we can test it using the OpenAI SDK. We'll begin by making our OpenAI client using our pipeline's URL and our Wallaroo auth token. Once created, we're able to use both the completions and chat completions functions as expected. Thanks to Wallaroo's thorough integration of the OpenAI API, we're also able to stream the generated tokens. Along with deploying to the operations center, thanks to Wallaroo's publish function, we're able to distribute our AI agents as AI inference microservices, allowing us to deploy them anywhere. Publishing a pipeline creates a fully self-contained deployment, pushing its artifacts to our private container registry, which we can then take and run on distributed remote environments. Best of all, because much like uploading our model and deploying our pipelines with our tailored parameters, publishing our pipeline can be done in a matter of minutes, helping alleviate bottlenecks in the distributed deployment workflow. Also, thanks to OCI compliance, these publishes can be deployed using Docker, Podman, or Helm. Regardless of hardware platform or deployment scenario, Wallaroo provides a consistent workflow for deploying publishes, enabling distributed inference close to where requests originate. Once our AI agents are live, we can leverage Wallaroo's powerful LLM listeners to observe them in production. With LLM listeners, we're able to monitor and validate our AI agents' outputs in an automated way, regardless of if they're in the cloud, on-prem, or a remote environment. Let's head to the Operations Center to see one of the LLM listeners we've set up. The Operations Center is our central way to manage, observe, and administer our artifacts with Wallaroo. In it, we'll find our Toxicity LLM listener, which we've deployed separately. Under the Insights tab, we'll find our Toxicity LLM listener, giving us the ability to observe our distributed AI agents at both aggregate and individual level. We're able to observe their outputs, allowing us to administer when they exceed our allowed toxicity threshold. As our agentic workflow matures, Wallaroo supports seamless lifecycle management, allowing us to update models, introduce RAG steps, and evolve our pipeline without disruption, making it easy to iterate, enhance context awareness, and scale complexity as our use case grows. To demonstrate that, we'll see how we can augment our pipeline with the addition of a context retrieval step, providing our llama with greater context prior to generation. Implemented using Wallaroo's flexible custom framework, our context retrieval workflow receives our prompt, embeds it using a BGE model, retrieves the relevant context with our MongoDB database, and returns a prompt with the context appended. Now that this step is ready, we can upload it as a model step using the same upload model function we used earlier. To it, we'll pass our model's step's name, file path, and the framework as custom. Once uploaded, we'll ensure that our model step is configured to be OpenAI API compatible. Now that our model step's ready, we'll move to creating our new deployment configuration. We'll find our engine and llama resource allocations are the same as our previous deployment configuration, but this time we'll also require resources for our new RAG step. Thanks to the level of abstraction Wallaroo provides, allocating these resources is as simple as adding extra sidekick steps to our deployment configuration. Once set up, we're ready to update our pipeline. Wallaroo's hot swapping capability makes the process seamless. Using our previous deployed pipeline, we'll clear it, add the model steps in the order of execution, and then redeploy. With minimal downtime, Wallaroo ensures our pipeline's endpoint remains the same throughout the whole process. And if our deployment is in a distributed environment, then we can go ahead and republish our pipeline, replacing our old publish, ensuring the right model gets into production wherever that may be while minimizing the impact to the business. We can now test our pipeline the same way as before, using the same base URL and API call. While the testing method and the API endpoint haven't changed, the output has. Thanks to our new RAG step, the generations are now more context aware and informative, resulting in richer and more accurate responses. And with that, we've seen how optimizing LLMs to migrating them across different silicon and deploying them in centralized and distributed environments, Wallaroo delivers a reliable and adaptable framework. We then saw how the added compatibility with OpenAI's API, Wallaroo makes it easy to integrate self-hosted models using familiar tools. Alongside being able to run our AI agents anywhere, we saw how Wallaroo's LLM listeners provided us the ability to observe and validate them wherever they may be, giving us automated insights into their behavior. Finally, we finished by seeing how, as those AI agents mature, Wallaroo gives us the flexibility to evolve them while minimizing interruptions to the business. With these capabilities, Wallaroo empowers teams while ensuring a consistent workflow across diverse platforms to deploy, migrate, monitor, manage, and evolve agentic AI workloads across any environment and hardware platform, ensuring optimized performance, a robust feedback loop, and comprehensive lifecycle management, giving teams the flexibility, confidence, and reliability to run AI agents anywhere.